Hello, this is our science teacher Tim Martin, and in this astronomy video I want to go over some of the features, structure, and history of our next door neighbor, the Moon. Let's go ahead and dive into some of the statistics. The Moon is approximately 3,476 kilometers across. That means it's about 27% of the Earth's diameter. Its average distance from the Earth is 384,000 kilometers. That's roughly 250,000 miles. It's much less massive than the Earth, only 1.2 times as heavy. Because of this, the Moon has approximately 1/6 the surface gravity of Earth. So you could think if you weigh 120 pounds on the surface of the Earth, you'd only weigh 20 pounds on the Moon. We've studied the Moon for a long time. Galileo may be the first to have used a telescope to study the Moon. It's worth noting Galileo didn't invent the telescope. Some Dutch opticians invented telescopes back in 1608. After hearing of the telescope, Galileo was very intrigued and he ordered one. Being impatient, he decided to build one of his own before the one he ordered arrived. The telescope that Galileo built was, in fact, better than the one he ordered. One of the first things we know Galileo looked at when he turned his telescope to the sky was the Moon. This picture on the right shows sketches from Galileo's notebook, where we can clearly see he saw craters, mountains, and valleys on the Moon's surface. We've studied the Moon for a long time. Here are several other interesting images. The picture on the upper right is the very first of the Earth taken from the proximity of the Moon. This was taken from an orbiting spacecraft in 1966. In the image on the left, taken by the Mariner spacecraft in 1977, we can see how small the Moon is in comparison to the Earth. The lower image from OSIRIS-REx, taken in 2017, shows us the true scale distance between the Earth and the Moon, where the Moon is approximately 30 Earth diameters away. Let's talk about the craters on the Moon. Craters are formed by asteroid impact. One of the things you may notice with a few of the craters are rays or ejecta. This is material that is displaced when the asteroid impacted the Moon. I like to think of this as splash marks. You may also wonder why there are so many more craters on the Moon as compared to the Earth. Well, 3/4 of the surface of the Earth is covered by water. We also have active plate tectonics and erosion. Because the Moon does not have any of these features, craters that formed millions and billions of years ago are still well preserved. One of the other obvious features of the Moon are the maria. Mare, or maria, plural, is a Latin word for the sea. These are the large dark regions that are easily seen on the Moon. Another feature worth noting is the terminator. The terminator is a line of sunrise and sunset that is easily seen in this first quarter image of the Moon. Many times it's easier to study the craters and mountains and valleys on the Moon. Because of the low angle of sunlight, tall mountains are illuminated and shadows are enhanced. Another note while we're talking about this image is the temperature on the Moon. The Moon experiences extreme temperature variations. Daytime temperatures on the Moon may rise well above 130 Celsius. In the night, it will drop down to a very chilly -170. Let's talk about the formation of the Moon. The leading hypothesis is the giant impact theory. It's likely that billions of years ago, a Mars-sized planetesimal collided with the protoplanet Earth. Why do we know this? We've discovered that the rocks on the Earth and the Moon have similar composition. This could also explain why the early Earth and the Moon were likely molten, and they slowly cooled from the surface going inwards. In this process, the molten material differentiated. Due to the force of gravity, more dense material coalesced in the center of the object, with the lighter silicate-type rocks rising to the surface. This theory also explains our synchronous orbit. We say the Moon is tidally locked. The same face of the Moon always points towards Earth. So, what does the backside look like? Remarkably, it's very different. We notice that the near side is covered with the dark maria, and the far side is absolutely covered by craters. So a word about the maria. They were likely caused by very large impacts. After these early impacts, molten material, or basaltic lava, rose to the surface and resurfaced this area of the Moon. At this point, it's worth noting a common misconception about the Moon. Some may guess that the reason why there are more craters on the far side of the Moon is because the Earth protects the Moon from impact. Well, it's helpful to go back to that image of the Earth and the Moon together. Keep in mind that asteroids would be coming in from all possible angles in space. Considering the enormous distance between the Earth and the Moon, as visible in this image, it's clear to see that the Earth will not be blocking asteroids from hitting the Moon. So why are there more craters on the far side and less on the near side? That is because of the uneven crust. As it turns out, the crust on the near side, or our side of the Moon, is only approximately 60 kilometers thick. The crust on the far side is closer to 100 kilometers thick. Understanding the difference in the thickness of the crust will explain why there are more maria on the near side. It was much easier for asteroids to puncture the thin crust on the Earth side of the Moon. Finally, a note about exploration. There have been over 100 missions to visit the Moon. The majority of those exploration missions were sponsored by either the United States or the Soviet Union. Recently, the Japanese Space Agency, the European Space Agency, and both the India and China space agencies have also sent spacecraft to the Moon. A few of the notable exploration missions. The picture on the upper left shows the Soviet Union-sponsored Luna 16. This was the first sample return mission, where the spacecraft landed on the surface of the Moon, collected samples, and returned some of those samples to Earth. Selene was a lunar orbiter sent by JAXA, or the Japanese Space Agency. It orbited the Moon to measure the Moon's gravity and studied the geology. SMART 1 was sent by the European Space Agency and was an orbiter designed to study the geology of the Moon. Chandrayaan, sent by India, discovered water ice near the poles of the Moon. The Chang'e missions were sent by the country of China. Chang'e 3 included a small rover, and it landed on the far side of the Moon. The rover drove around and performed experiments for over 40 days. Likely the most significant exploration of the Moon occurred in the 1960s and 70s by NASA, the space agency of the United States. Although there were more missions, 6 of the Apollo flights landed on the surface of the Moon. Each mission included 3 astronauts, 2 who accompanied the lunar lander down to the surface, and 1 who stayed and piloted the command module in lunar orbit. Several of the later of the Apollo missions included the use of a lunar rover to drive around on the lunar surface. The astronauts conducted many experiments and collected many samples. These samples were returned and studied back here on Earth. It's likely in the next few years or decades, astronauts will once again return to the Moon and then possibly to Mars or other locations in the solar system. Thanks for watching, and I hope you join me again on another astronomy or earth science video.